carbon and its compounds. In this chapter, you will study about various carbon compounds and the type of bond present in these compounds. What are carbon compounds? These are compounds which contain carbon as one of their constituent elements. There are two types of carbon compounds called as inorganic compounds and organic compounds. Carbon dioxide, calcium carbonate, calcium bicarbonate, sodium carbonate are all inorganic compounds of carbon, whereas glucose, cellulose, proteins, starch, vitamins are organic compounds of carbon. In the Earth's crust, carbon is present in the form of carbonates and bicarbonates. In the Earth's atmosphere, carbon is present as carbon dioxide. In the previous chapter, we have studied about ionic compounds. The various ionic compounds are sodium chloride, calcium oxide, magnesium chloride, magnesium oxide. We have also studied the properties of ionic compounds. We know that ionic compounds have high melting and boiling points. You can see the table, the values are given. So why do ionic compounds have very high melting and boiling points? It is because of the presence of the strong interionic forces of attraction. Ionic compounds are also good conductors of electricity. What is it due to? It is due to the movement of ions. We know that ionic compounds contain ions. The particles present are ions, and it is due to the movement of ions that ionic compounds can conduct electricity. Now let us consider the case of carbon compounds. Consider the carbon compounds like acetic acid, chloroform, ethanol, methane. The melting and the boiling point of these compounds are given. From the values, it is clear that they have comparatively lower melting and boiling points. Why is it so? It is because the type of bond present in carbon compounds is different. It is not an ionic bond which is present in compounds like acetic acid, chloroform, ethanol and methane. So let us now study how the bond is formed. To understand the type of bond present in carbon compounds, consider the electronic configuration of carbon. We know that the atomic number of carbon is 6 and its electronic configuration is 2, 4. 2 electrons in the K shell and 4 electrons in the L shell. Usually, atoms combine with other atoms so that they can get octet configuration or 8 electrons in their outermost shell. So how can carbon get octet configuration? By gaining 4 more electrons. If carbon gains 4 more electrons, the number of electrons now present will be equal to 10, whereas the number of protons is only equal to 6. When carbon gains 4 electrons, it changes to C4 minus. And it is found that 6 protons cannot hold all the 10 electrons. It means carbon cannot form C4 minus ion. Consider the next case, that is C4 plus. Cation C4 plus is formed when carbon loses 4 of its valence electrons. But it is found that a large amount of energy is required to remove the 4 electrons. Therefore, it means that carbon cannot form C4 plus ion. So, it is not possible for carbon to lose or to gain electrons. So, how can carbon get octet configuration, or how can it combine with atoms of other elements? By sharing its electrons with other atoms. It is not only carbon which shares its electrons with other atoms. Atoms like hydrogen, fluorine, chlorine, nitrogen, oxygen, can also share the electrons with other atoms. So using Lewis symbols, let us now try to understand how the bond is formed by the sharing of electrons between atoms. Consider Lewis representation of formation of bond. The bond which is formed by the sharing of electrons between atoms is known as covalent bond. Consider hydrogen molecule. Each hydrogen atom has one valence electron and each hydrogen atom requires one more electron to get a stable configuration. Therefore, each hydrogen atom contributes one electron for sharing with the other hydrogen atom. Since two electrons are shared between the two hydrogen atoms, a single covalent bond will be formed. Now consider chlorine molecule. Each chlorine atom has 7 valence electrons and each chlorine atom requires one more electron to get a stable octet configuration. Thus, a pair of electrons will be shared between two chlorine atoms. Therefore, a single covalent bond is formed between two chlorine atoms in chlorine molecule. Consider fluorine molecule. Each fluorine atom has 7 valence electrons and each fluorine atom requires one more electron to get a stable octet configuration. A pair of electrons is shared between two fluorine atoms, therefore single bond.